Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 3 in the command injection module titled Blind OS Command Injection with Output Redirection. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down, select command injection, go down one more time to lab number 3 titled Blind OS Command Injection with Output Redirection. Alright, let's get started. This lab contains a blind OS command injection vulnerability in the feedback function. The application executes a shell command containing the user supplied details. The output from the command is not returned in the response. However, you can use output redirection to capture the output from the command. There is a writable folder at var /images. The application serves the images for the product cataloged from this location. You can redirect the output from the injected command to a file in this folder, and then use the image loading URL to retrieve the contents of the file. To solve the lab, execute the whoami command and retrieve the output. Okay, so the target goal is to exploit the blind command injection vulnerability and redirect the output from the whoami command to this folder right over here. So this has a couple of steps. The first one is we need to confirm that a certain parameter is vulnerable to blind command injection. Once we confirm that, we need to find a place in the application where we could redirect our output from the command injection. So we're going to find out where the images are stored, because we're told over here that there are images that get stored in the public directory, which we can write to. Now, in a real world scenario, you don't know that, so you have to try to see if it's possible. The third step is redirect the output to an image in that folder. And then the fourth step is to check if the file was created, or if it's overwritten if you decide to overwrite a file that already exists. But we're not going to do that because that's destructive, and we're going to create our own folder. All right, let's save this. Click on Access the Lab and open it in a new tab. And while that opens up, we're going to open up Burp Community Edition. Hit OK. Hit Next. Start Burp. And let's close this right over here. Okay. So set Foxy proxy extension to send request to Burp, and then click on the Submit Feedback page, and we could see over here it's intercepted in Burp. Let's turn that off and just work from HTTP history. So if we submit feedback over here, so let's say test.test.ca, and subject is just test, and again message is just test, and submit feedback, you could see a post request being performed over here. Let's send that to repeater, and let's put this right over here. Okay, so the first step is to confirm that one of the parameters is vulnerable to blind command injection. Now we can test each parameter like we would in a real world scenario. However, because we did solve the exact same exercise in the previous lab, what we're going to do is we're just going to test the parameter that we know is vulnerable to command injection, which is the email field over here. And again, the way you do that is you could concatenate commands using the end character, and then ask the application to sleep for 10 seconds before it outputs the response. And this confirms that we have a blind command injection. So Control U to URL encode it, hit send, and let's see if it takes 10 seconds for the application to return a response. And it looks like it does, because we're waiting for an unusually long time. It usually takes like a second or two for it to run. And here we go. It takes a little bit longer than 10 seconds in order for us to get the response back. So we've confirmed that this is definitely vulnerable to command injection, and the parameter we're working with is the email field. Next, we need to see if we could exploit this command injection in order to exfiltrate data from the application or the host operating system. And just getting the application to sleep for 10 seconds is not very useful. So what we're going to try and do is try to output data in another page in the application that is publicly visible to us. So if we go back to proxy over here and we look at the HTTP history, you could see over here there's submit feedback and so on, nothing that we could use. So we're just going to go to home and see if there's anything we could use over here. And notice over here it says an images folder, and it's removing the requests for images because in the filter by default over here it doesn't add images. So I'm just going to add it over here and then go back, and you could see over here there are images that are getting displayed. Then each image has a file name, and the file name over here is sequential, and then it displays the content of the image. So what I'm going to do is I'm just going to send a random one to myself over here, send to repeater, and hit send. And notice over here it gives me the content of the image. So there is a place where it saves images, and usually that place is in the var // images folder. So if I can write to that folder, I might be able to include my own file that contains the content of the command that I want to run. So let's try that. If we go back to repeater over here, what I'm going to do is, instead of asking it to sleep, let's remove that. I'm going to say run the whoami command, but because I won't get the output of the whoami command in the response, what I'm going to say is redirect the output of the whoami command into a file in var // images, and let's call it output.txt. So what this does is it runs the whoami command, and then it saves the content of the whoami command in a folder called output.txt that is available in this directory over here. So again, let's add the hash sign so that we don't run into any errors. And then Control U to URL encode it. And let's hit send. We get a response right away. We're still not sure if this worked. So what we're going to do is we're just going to see if the file exists. So output.txt, hit send, and it does. All right, perfect. So you could see the output of our whoami command is this right over here, which is the name of the user of the system. So if we go back to the list of steps that we said we will perform, we check to see if there is possibly a place in the application where we could write, and there was, and it's in the images folder, and then we redirected the output to a file that we created there, and then we outputted the content of the file. All right, so we successfully completed the exercise by manually exploiting the vulnerability. The next thing we're going to do is script the exploit. And again, if you're new to this channel and have no idea why I'm scripting this exploit, it's because I truly believe that in order for you to be a really good pen tester, you do need to have scripting skills, and so I script all my exploits in Python. Okay, the first thing we're going to do is import the requests library, because that's the library that allows us to perform HTTP requests. And then I'm going to import the sys library and the URL lib3 library. I'm also going to import the beautiful soup library. And the reason I'm going to do that is because I need to extract the CSRF token. So if you look over here in the request that has the command injection, there's a CSRF token that gets passed in the request, and if that CSRF token is not there, what's going to end up happening is it's going to give me an error saying it's missing a parameter called CSRF. So I need to be able to extract it from the previous request and then use it in this request in order to perform my command injection exploit. And we'll do that by parsing it using the beautiful soup library. Next, let's add this line over here to disable warnings when it comes to TLS certificates. So .exceptions, .insecure request warning. And I'm going to set proxies to be equal to HTTP 127.0.0.1 running on port 8080, which is my burp proxy. And same goes for HTTPS. And the reason I do that is because I want all my requests to be sent to Burp before they're sent to the application, and any responses from the application get sent to Burp before they get sent to my request. And that's purely because I want to debug my script in case it doesn't work as intended. Okay, next, let's add the main method. And we'll create it right over here. So we're going to say if length of the command line arguments is not equal to 2, then print the usage and the example instructions. So we'll start off with the usage instructions, which is the name of the program and the URL of the application that is vulnerable. And then we're going to print the example instructions. And let's say www.example.com, and again the name of the program. And let's exit the program because it wasn't run correctly. Alright, so this block of code runs if the user doesn't run the program with the correct number of arguments. Now, assuming that the user runs the program with the correct number of arguments, the first thing we're going to do is we're going to take the first argument and save it in a variable called URL. And then we're going to print this statement right over here saying exploiting blind command injection in email field. Next, we're going to use the session variable over here in order to persist the session. So we need to be able to extract the CSRF token from the feedback page before we use it in the page that is vulnerable to command injection. And this line of code over here will allow us to do that. All right, next we're going to run a function called exploit command injection, which we'll write in a bit. And it takes in the S variable and the URL variable. Okay, let's write up this function over here. So exploit command injection. We're first going to create a variable called submit feedback path. And that's the path to the page that is vulnerable, which is this one right over here. So let's copy this. And put it in here. And I don't think it copied correctly. So let's copy it again. Okay, this looks good. Next, we're going to add our command injection string. So that was this one right over here. So let's say test at test.ca. And then we're going to run the whoami command and redirect it to this folder over here. So var dub images, and let's say output2.txt so that we don't confuse it with the first one that we ran. Okay, this looks good. And what I'm going to do is actually send this request so that my application doesn't time out, and it already timed out, so that's fine. We'll just have to run it again. Okay, next I need to extract my CSRF token. Because you could see over here the CSRF token gets passed in the request. And if let's go back to see that. Here we go. So the CSRF token gets passed in the request, and if it's not, it'll tell me that I'm missing a CSRF token. So I need to be able to extract it somehow. And the way I'm going to do that is by writing my own function that extracts it from the previous request. And we'll write that in a bit. So that we don't forget to write it, what I'm going to do is I'm just going to create the function. And I'm just going to add a line of code that says complete later. Okay, this looks good. Next, we need to add the parameters of the request before we perform the request. And the first parameter over here is the CSRF token. So let's add that, CSRF. And the value of the CSRF token is going to be this variable over here. So CSRF token. The next parameter over here is the name variable and then the email variable. So let's add name. That's just, let's say, equal to test. And then the email variable or the email parameter, and that's equal to our command injection over here because that's the parameter that is vulnerable to command injection. So we're going to add command injection over here. The next parameters are submit and message. So let's add those. Again, just test and message. We'll just say test again. Okay, this looks good. Now let's perform our request. So s.post, and the reason we're performing a post method is because it's a post request right over here. So we've got URL plus submit feedback path, and then we're going to say data is equal to data. That's the parameters that the request is taken, which is right over here. And then we're going to set verify to be equal to false, and proxies to be equal to proxies, so that the request goes through burp first before it gets sent to the application. And again, this is really helpful when it comes to debugging why the script is not working as intended. Next, I'm going to print verifying if command injection exploit worked. And so over here, what we did is we essentially performed this request over here where we redirected the output of the whoami command to a file called output.txt. Now the next thing we need to do is verify that our command injection worked by seeing if this file exists, and if it does, then print the content of the file. And that's what we're going to do right over here. So let's add a comment saying we're verifying the command injection. And the way to do that is we need the path to the file. So that's this over here. And it's output2.txt. And then we're going to perform another request. And this time it's a get request because this is a get method over here. And we're going to say URL plus file path. And then we're going to set verify to be equal to false because I don't want to deal with TLS certificates. And then we're going to set proxies to be equal to proxies because I want the request to be sent to burp. And then I'm going to say if res2.status code is equal to 200, which means that the file exists. That means that the command injection worked. So we're going to say command injection successful. And we're going to output the content of the file because we do want to see the output of the whoami command that we ran. So I'm going to say the following is the content of the command, and we'll add it right over here. So res2.txt, text, which is the response of the request that we made. Okay, now if we don't get a 200 okay message, that means the command injection failed. So we're gonna add a string over here or a message over here that tells us that the command injection failed or was not successful. Let's save that. Remove all the extra lines. Save that again. And we still have one thing to complete, which is getting the CSRF token. So let's do that right now. Now we're going to get the CSRF token from the request that is performed before this request over here. So we're going to say feedback path is equal to, and the request, the path to the request over here is right over here. So before it performs the submit request for the feedback form, it performs a get request for the feedback page. So that's our path right over here. So let's copy that. And then we're going to perform the get request. And the reason we're performing a get request again is because it's a get request that is being performed over here. So we're going to say URL plus feedback path and set verify to be equal to false because I don't want to verify TLS certificates. Set proxies to be equal to proxies so that the request passes through burp. And that's where we're going to use the soup library or the beautiful soup library. So we're going to say soup is equal to beautiful soup and the response of the request that we just performed, and we're going to parse it. So html.parser. Now over here, if you look at this and look for CSRF, actually let's look for input. So the first input variable over here is the CSRF variable. And if you look at the value over here, it's the value of the CSRF token. So we're going to extract that using this line over here. So we're going to say CSRF is equal to soup.find. And we're going to say input and obtain the value or the string that is stored in the value field over here, which is this string right over here. And then I'm going to return it. And now when this returns it, it returns it over here. It gets saved in the CSRF token variable, and then it gets passed as a parameter in the request. Okay, so this looks good. It's a ton of code, so, well, not too much code, but we might have mistakes in this. So let's run it and verify if it works. So terminal, new terminal, and Python 3, command injection, lab03.py, and we need a link to the application. It timed out, so we have to run it again. Okay, let's copy that and put it over here and hit enter. And we do have an error, so if we go back over here, it's actually from BS4 import the beautiful soup library. Let's save that, clear it, and I do want to see burp right in front of me because I want to see the request being performed. All right, let's run it again. Okay, so no errors, that's good. So it's telling me that it's exploiting the blind command injection in the email field. And so what it's doing is it's performing the get request in the feedback page in order to extract the CSRF token. So this one right over here for HTHPPP. Once it extracts it, it performs the command injection vulnerability. And over here, it's saying it's missing the parameter. So it's missing a certain parameter over here, and I'm not sure which one. And I know what it is. It's the images parameter. And that's why it's really useful to set the proxy setting over here. So proxies is equal to proxies, because now I know that the command injection didn't work, but I'm not sure why. However, when I look through the requests in burp, I can see why it's not working. So if we go back to our data variable and we look over here, you could see that we're actually missing a variable. So if we go to repeater, there is name, which we have, and then there's email, which we have, and then there is subject, which we don't have. Instead, we set submit by accident, so let's change that to subject, save it, and run it again. And again, let's go to history so that we see the requests. And run it one more time. Okay, Perfect. So over here, it performs the GET request and it extracts the CSRF token again, which is this value right over here, MEUHZ, and then it puts that value in the request that is used to perform the command injection. This is where we create a file output2.txt and we save the output of the whoami command in it, and then we check if that file exists. It does, so it gives us a 200 OK message, and so it prints the content of the file, which is the name of the user that is running on the system. Alright, so we successfully completed the exercise by exploiting a blind command injection vulnerability in order to extract information from the operating system. In the next lab, we'll look at another type of blind command injection vulnerability where you can't write to a file and so can't extract data from the system through the same way that we did over here. So instead, what we're going to do is we're going to try and interact with an external server that we control, and from there we'll extract information from the system.